There we go. Okay. I was speaking about the 3 levels that we work on, which is your level 1, which was your instruments. Okay. We know that we had level 1, which is your instruments, and then we had level 2, which is your controller part, where the instruments are feeding information to the controller. And then the controller needs to make a decision and then send to the level 3, which is your final controller part, which is where you find your actuators and so on. The muscles to do correction. Excuse me. Now we are going to look at the overall setup of this system, which is known as your overview for plant communication. These are the objectives that we are going to cover today. You know, if we look at all enterprises, all right, and the idea is for them to be quite productive. Okay, what do I mean by that? It means that they constantly need to improve their processes, okay, in whatever they are doing. In any enterprise that you will go to, that is always the objective. Now, how do you achieve that improved processes with more productivity? It needs to have accurate data, okay? And for you to get accurate data, communication is very important, okay? Everything that we try and get into our system, it's always based on the collective of data. And when you collect that data, it is also very important to have accurate data, okay? And through that, we make use of communication. Now, production devices, which now are our instruments, they hold very important data when it comes to the process that's required in our enterprises, okay? So in this chapter, we will look at how all this data is collected and how can this data contribute into the productiveness of the enterprise. So the first thing that's going to help us to go through that, we'll describe the 4 levels of plant communication and their characteristics at each level. That's the first thing that we're going to look at. And then we're going to compare the contrast human communication and the machine communication. And once we have done that, we're going to define terms such as serial, synchronous, RS-232, RS-422, device, cell, area, host, and SCADA, because all what I just mentioned, they are part of the communication that is quite vital for our enterprise. And then we're going to describe how a computer can communicate with our PLCs, okay? And then we'll explain the concepts of MAP as well as TOP. And if you're asking yourself, what is MAP? It's actually your manufacturing automation protocol. And then your TOP is your technical office protocol. We're going to go deeper and understand what do we mean when you talk about manufacturing automation protocols, as well as what do we mean when you talk about our technical office protocols. And then we'll describe the opportunity available through factory communication. And once we have covered all these objectives, we will understand fully how the plant flow communication part 1 operates, okay? Now, let's first look at our level that I mentioned previously, the levels of plant flow communication. As I mentioned earlier on, the plant flow communication can be broken down into 4 levels. And these 4 levels are your, I'm trying to get my pointer here. It will be your device level, and then it followed up by your cell level, and then it followed up by your area level, and then it's concluded by your host level. At some point, they also refer the device level into the field level as well. And on our right here, we have, I would call them components that exist in these 3 different levels, okay? As you can see that on device level 1, we've got all our instruments, our sensors, our transducers, and so on. And then in cell level 2, we've got our HMIs, we've got our mini PLCs, and then we also got our industrial computers. And then in area level 3, we've got our office computers as well as our smart, PLCs that are actually doing all the SCADA system. And then in our host right on top, we've got our office computers, okay? Each level has a very important link to the previous level, okay? And the device link is the production level, okay? As we move up to the pyramid, management of production becomes the most vital component. And the easiest way to understand this model is actually to relate it to us people on how we actually operate when we go to in a work environment, or when we go to any enterprise where there's a organogram or hierarchy depending on your experience. So the next slide will actually give you a comparison between us human beings as well as the electronics instruments that are found in these different levels in our plant flow communication. This is what I put on the slide, where I can give you a better understanding of these levels of plant communication. If you look at the pyramid on the left, this is what we as human beings are used to when we go to a work environment, where at the device level, which is right at the bottom, this is your device level right here at the bottom. When you compare to us, this is where you get your production personnel, okay? And this is where you'll find general workers that's supposed to do certain tasks that are required by the production sector or any enterprise. And then these general workers, they need to report to what we call a foreman, okay? And in this case, a foreman, we can actually refer it to the cell level, okay? Now, the foreman oversights what different groups of production personnel are doing, which I will explain that later on when I'm referring to the pyramid on the left. And then now the foreman needs to report to what we call a supervisor, okay? Now, a supervisor, in this case, we refer it to our area level, okay? And then now the supervisor will monitor what is happening through the foreman. And now you have to also take this into consideration. Communication needs to be consistent with the foreman from these general workers, the production personnel, the people who are doing the hard work. And then the foreman needs to be able to combine or collect this information that it's getting from the production personnel and send it to the supervisor, or summarize it and send to the supervisor what he feels it's important for the supervisor to know. And then the supervisor, based on the information, which is now the data that he received from the foreman, he will also make decisions that will request the plant manager to make very important decisions. And now the plant manager, when it comes to our level of plant communication, we are referring it to as the host. Okay. The reason I have this comparison of a plant model and a typical industrial organization of people, I always believe that it makes it much easier for you to understand what is happening in this pyramid over here in the plant, where you've got your device level, and then you've got your cell level, and then you've got your area level, and then you've got your host. If in your mind you have what's happening on the pyramid at the left, I believe that this will be easy to understand. Okay. Now, I always said that if we think of a typical duties that each personnel would have to do at each level, then it will be easier for us to understand the functions that these guys are supposed to deliver. And those functions are quite similar to the functions of these electronic devices that you need to understand here. Even when now you configure a complete plant, this pyramid will always be like this. Whether you're looking at the wastewater treatment plant, or you're looking at the automobile plant, or you're looking at a power system plant, this structure will always be like this. In fact, even in our institution, now I'm referring to CPUT, we are applying this structure as well. What is happening? You've got your device level, which are your lecturers that are teaching you guys. And then these lecturers, they need to report to the HOD, which the HOD is sitting right here on the cell level. Okay. And then now the HOD needs to report to the deans, and the deans are sitting right over here. And the deans, where do they report to? They report to the vice chancellor, which is sitting right on top there. So now the vice chancellor will make decision, and then he will convey that information to the dean, and then the dean will call the HODs, and then the head of department will call the lecturers, and the lecturers will apply whatever task is done there. So the vice chancellor, for him to make a conclusion to say Cape Peninsula University of Technology is doing well, it's the accurate information that he has received right from the bottom, through the cell, through the area, through and up until it reaches him. So that's the whole process of how this communication works. I hope I'm clear. Any questions before now we go deeper? Because now what's going to happen? Now we're going to go deeper and understand exactly what is happening here with respect to communication. Remember, in your level, you already know all the functions of these devices right at the device level. But now you need to know the communication part and how, once they've communicated, what happens to the next level. So now the next part of the rest of today, we're going to go deeper on device level, deeper on cell, deeper on area, and then we conclude with the host. That's the whole idea of today's lesson. So while I'm at this chapter, at this slide, do you have any questions in terms of understanding what's going on here? Okay, nothing?
No, sir, it's okay.
Okay, thank you, man. All right, let's proceed now to the next point. Now, this is our device level. Now, you always try and picture that pyramid that I just explained, because now we are going deeper into that device level, okay? The device level is the lowest level of control on our plant. That is very important. This is the lowest. This is the general workers or the production, where the production is taking place. This is where you find your lecturers, where the real work is happening. At CPUT, we know very well that our bread and butter is the students, and the student needs to be taught by lecturers. So this is the part here. That's the lowest level that you can get, okay? Now, this part here, you will find devices such as your CNC machines, which are your computer-controlled machine tools. Sometimes you'll find your basic PLCs. You'll find your conveyors. You find your sensors there, your hard automation, your transmitters, your actuators, your valves, and your pumps. This is where you find all that stuff. Now, if you look at all these devices I'm referring to, you can see that they've got quite several things that are in common, okay? Now, again, let's refer to you guys as students. My students in my process instrumentation 3, if you guys look at each other, most of you, you've got things that are common. What are those things? All of you have passed process instrumentation 1. All of you have passed process instrumentation 2. So the fact that you guys are sitting in process instrumentation 3, it means that you guys got several things that are in common. You've got understanding of the subject that you are sitting in. So it's a similar setup also when it comes to the device level. Those devices that are sitting at that level, they more or less have several things that are in common, okay? And these are the devices or instruments that are used to handle production, okay? Now, these equipment or devices, they are directly involved with the product. What do I mean by that? Where you've got your raw product coming into your plant, okay? These devices are the first things that meets that raw product that now needs something that needs to happen. The conveyors need to move certain boxes. The sensors need to sense how many boxes have been moved and so on. So that is where now I say all these devices are directly involved with the product. Some they move the product from left to right, some they add the product and so on, okay? Now, if you take the very same application and you bring it into a human model, this is where it relates to our production personnel, where the objective is to add value to the product. And this is where you will fill out your paperwork, you check in, you monitor the quality, you look at the productivity, you make sure that each device needs to be programmed, and you tell it what to do and when it must do that and so on. And this is where all that is happening, okay? And you always now need to remember that this is the most important level where a lot of things needs to happen, you know. And I like relating to humans because we know that when we work together, we know who must do what in that group in order for us, end of the day, as a team, we produce something that is important or valid to the company. So this is where all those things are happening. One of the other things that the devices have in common is the information, the need for data. Okay? For you to make a decision about anything, you need to be informed. So it's a similar thing with this device level. So at this point, that is the most important part that you need to understand about the device level. Now, you can go deeper and understand a particular instrument. What does it do? Like if you remember last time we spoke about our ultrasonic transducers, we spoke about strain gauge transducers, we spoke about capacitive sensors and all those things. All that information with the measurements through those sensors and conversion through transducers, that is the data that is very critical that eventually needs to be sent. When those instruments are busy doing all those functions, at the same time, they are storing data, okay? When a sensor is monitoring how many boxes are sitting on a conveyor and how many have passed at a particular time, when that sensor is counting that object passing there, remember, what is it doing? It's storing the amount of those boxes that have passed. If 10 of them has passed, it will store that 10 boxes has passed. Now, that number 10 is the data that's very important because that number needs to be sent to the foreman to say, yes, today we counted X amount of boxes, and in these boxes there was X amount of product. And that information is accurate information that needs to be sent to the foreman. And then the foreman needs to collect that information and also collect a different information for another group, and then make a conclusion and then send it to the supervisor. So the device level is very, very important part of the whole plant flow communication. Okay, and then now we move to the next level, which is our cell level. And this is our cell level. Remember now, this is the second level after the device level. Now, the cell level is a logical grouping of devices used to add value to one or more product, okay? And the cell consists of various dissimilar devices, okay? And the cell will typically work on a family of similar parts, okay? Meaning the grouping that the cell does, it does the grouping similar to the functions of the devices. If you've got devices that are sensing certain product, they will group together for sensing. And then if you've got devices that are actually for moving the product, all those devices that are doing the movement will be grouped together, okay? And each device typically has its own unique type of program as well as communication protocol, okay? So now you see I've touched another very important term there. I say to you, each device typically has its own unique type of program as well as a communication protocol, okay? You will see when we talk about communication protocol, even us as human beings, we've got our own communication protocols, okay? Devices do not want to communicate with each other. You will find out that when the devices are actually doing their functions, their objectives is to just do what it's required to do. They don't necessarily bother themselves with what's next to them. What do I mean by that? If you have a sensor that is sensing an object that is moving on a conveyor, that sensor does not care about that conveyor. The only thing that it's doing, it's monitoring the device or the object that is actually on the conveyor. That's what that statement means when they say devices do not want to communicate with each other. They just want to do their task. Okay. Then I said, for example, if you look at the CNC machine, it does not want to communicate with the robot. It just want to do its own functions as a CNC machine. If you don't understand what I'm saying, I always like to take it to the human model. When it comes to a human model, the foreman, which now is the cell controller, remember foreman is just above the device. The foreman's job is to show up at work and find out what needs to be produced for that day. Then now what it does, once it has find out what needs to be produced for that day, it will choose an appropriate production person to perform each task that it needs to be applied for that day or accomplished for that day. So it won't bother with other personnel that does not need to produce any production for that particular day. And now that is very critical when you are a plant technician or technologist and you want some certain production to be accomplished for that particular day. You need to know exactly which group you need to work with for that particular day. Because if you look at a plant holistically, there are a lot of activities that are happening there. But if today our objectives is to print, maybe let's say it's a printing plant machine, is to print the names of a particular company. Let's say maybe we need to print names in our bottle that it's written Coca-Cola. And we've got our bottle sitting there, and now we need to print this name Coca-Cola. We're not going to care about the group that is actually manufacturing the bottles at that point. No. Because we've already got our bottles sitting in our store, and the objective is for us to get those bottles and get them printed. So it's something similar to that. However, you must also note that all people have different personalities. I mean, we all know that, okay? So why am I going to the personalities? A good foreman can communicate well with each individual. That is very important. If you've got a very good foreman, productivity can actually multiply, okay? Because you know who to speak to in order for you to make sure that this message is passed and reached, received smoothly, and you know who to talk to if you know that this message is going to struggle or they are going to sugarcoat the information. By the time it reaches the point of destination, there's issues and so on. So the foreman then monitors each employee's performance, and by coordinating their efforts, which is based on what they have produced for that particular day. And then the foreman will make sure that people cooperate to get the overall job accomplished. So you can see that the foreman plays a very big role in terms of how the overall job is accomplished. And now that is our cell. All these functions that we are referring to your human model is exactly what the cell level will do, okay? Going back now technically to the cell, all right? The purpose of the cell, which we also refer to as a controller, is to integrate all these various devices into a cooperative work cell. The cell controller must then be able to communicate with each other. Even if devices are not able to communicate with each other, they must be able to communicate with the cell controller. So the general workers, even if they don't have to speak to each other, but they must be able to speak to the foreman individually, okay? then the cell controller must be able to upload or download programs, exchange various information such as start, stop the device, and monitor the performance of each device. So you can see now that the devices here at the bottom, all these devices here, they need to listen to the cell, okay? Although they're not able to talk to each other, but they need to be able to send information to the cell. Now, the cell himself needs to be able to see what information has been sent to them and then able to send back the required instruction into the devices. And now this needs to be done holistically so that they accomplished the required task for the day. Okay? And that is very important. Okay? Now you ask yourself, okay, now here we are going deeper into communication. I said to you that the PLC needs to speak to the cell level, okay? And how is that accomplished? That's very important. And then you also want any device here to be able to send information there, as well as that one there. And then make a decision and then bring here and tell this robot to do that and so on. So what is used to do this communication? What is used? What type of modem is used to get this communication going? Okay. Now that's where we are going. All right. There are actually two main types of communication that we are going to look, but those are not the only communication. Okay. So the first one is your primitive communication. We're going to first look at the primitive communication. Okay. And this one here is quite a popular one. And then I'm going to explain how this one works. As I stated that some devices do not have the capability to communicate. Okay, what does that mean? Some simple PLC, for example, cannot communicate serially with other devices. Now, in this case, primitive methods are used. Okay. Now, in a primitive mode, the device basically just handshake with few digital inputs and outputs. Okay, now things are starting to get complicated. How do I apply this primitive? Let's say, for example, a robot is programmed, okay, to wait until a particular input comes true before executing the program. So in a case like this, we will have now to connect some cable to input. We can choose input 2 or input 1, doesn't matter. And then once that input is high, and then now the robot needs to execute a certain program, okay? Now, when that program is being executed, we can tell now that program that once the program is done, we want output 1 to be high. Okay, which output 1 now? The output 1 that is coming from the robot, because the input of the robot was activated. And then once that is done, the PLC output can then connect into that input 1 of the robot, and then the output 1 of the robot can be connected into another PLC. And now that process is simply called your primitive communication, okay? Where a PLC can command the robot to execute or not to execute, all right? And when the program is complete, the robot will actually notify the PLC and say, the program is complete. And how does it do that? It does that by a simple yes or no binary information, high or low. So that process is just a basic primitive communication. Okay. Now, what resources do we use to connect this? Surely, I don't know, based on your experience, you will find out that once you have a physical PLC, when I say a physical PLC, I'm referring now to the PLC in the lab. You will have your program in your computer. And that program in your computer, you know very well by now how to program a PLC in a computer, which is what we did last semester. Now, the program that you have done in your OB, in your organization block, it has input and outputs. And those inputs and outputs, they are connected, they should be connected to the real devices, okay? For example, if we want to run a three-phase motor, we know very well that the input needs to be energized, and then once the input is been energized, the program is executed, and then it produces output, and then the output runs the motor. So that process of signal coming into the PLC, going out into the device that you are driving, is referred to as your primitive communication. But now, which resources do we use to connect this? And this brings us to the next slide. If you look at the next slide, we are looking at different devices that can offer more communication for us to be able to accomplish our objective. I state here that many devices offer more communication capability, and most devices offer serial communication capability, where we use RS-232 serial port that are available. Now, you guys are quite familiar with these serial port, or maybe, let me correct it. In nowadays, I don't think we get computers with these serial ports anymore. We are using now what we call USB, HDMI, and so on. We're no longer using these serial ones. So initially, this is where the communication started. If you look at, the front view is this one here of your serial port communication. And here, this is your top view, okay? And this one here is your side view. As you can see, this one here, it's a 9-pin RS-232, and this one here is your 14-pin, and so on. You get different serial ports out there. Now, these issues, these resources help us to solve some issues when it comes to communication. Many devices offer more communication capabilities, like I said. For example, sometimes we need to upload or download the program into the device, okay, or into the PLC. You will see when we work with our PLC in the lab, there will be a cable called MPI, all right, where you will connect it into, you will connect the other, I would say the head into your USB port instead of the serial port. And then the tail will be connected into the PLC. And then the software, the program that you did on your OB will be now sent into the real PLC through that communication medium, okay? And before that, they were using these serial ports. Hence, I had to start with these serial ports. Why? Because we are looking at this particular protocol, which is RS-232, okay? Okay, sometimes you'll find out that there's issues of capability between these two devices, your PLC or any device and your computer. And you'll need now to add a converter or an adapter in order to accomplish your objective, which is sending information to the device. And in that case, we use a basic topology to do that based on the wiring of these 9 pins, okay? You are not assigned to connect all these pins when you do the connection. Now I'm referring to this modem over here. Sometimes you find out that not all pins are active, only certain pins are active based on the application that you want to do, okay? Now, this RS23232 standard specifies a function for each of these 25 pins that I mentioned, and it does not say that any of the pins must be used. However, some manufacturers use only 3 of these pins as shown in this figure that I'm showing below. Now, this figure here, you'll find out that in this case, you have only 3, meaning you only got, okay, I want to start this in a very nice, simple way. You've got your computer on the left. I don't want to spend too much theory because it's going to confuse you. You've got your computer, and then here you might have your PLC, but in this case, they just put another computer. Now here, you've got information that needs to be sent to this device over here. This concept is coming from this setup here, where you've got your device at the device level, and it needs to send information to the cell level. So try and picture that in this case, okay? Now, in this case, they're using 3 pins. What do I mean by that? There's a thing that is called handshaking, okay? Now, handshaking means that when this device is here, when this device here needs to send information here, it first needs to acknowledge that there is a device on the receiving end. Now, when you don't have the function of handshaking, it does not know that there's a device at the receiving end. What it does, it assumes that there's a device at the receiving end, okay? So this is when you only got 3 pins that are used for that. So what happens here is the first computer, which is this one here, will send information via pin 2, okay? And then the second computer will receive that information via pin 3. Now I'm looking at the sending and the receiving end. And then once it has received it, it just stays like that, okay? There's no acknowledgement. There's hopes that it has sent the information. As well as when this now changes, where now this one becomes the sender and this one becomes the receiver, pin 2 will send information and pin 3 will receive information. And they've got pin 7 as their common ground, okay? But there's no acknowledgement whatsoever. Now, that was how initially the communication started to happen. You will send information hoping that the receiving end received the information. No acknowledgement, nothing, okay? And then now what they did, they said, look, this is a problem because I can unplug the receiving end and the sending end will still continue to send information there, and we'll have problems. So now we needed now to come up with a system that will be able to acknowledge each other when it comes to this process. Okay, this is where now they introduce what we call handshaking. Okay, now what is handshaking operation implies? The first computer tells the second computer that I have a message that I would like to transmit. And then what will happen? It will acknowledge that information. But now, how do you accommodate that? That is where now you introduce the fourth pin. Okay, let's go back to our case here. Now, we used pin 1. Just get my pointer here. We used pin 1 and pin 2, okay, and pin 3, and then we used pin 7, okay. But now they said to us here, depending on the topology here, we can also add another pin that will actually tell us that do we have another device acknowledging that now we're about to send information. So now coming back here, we'll introduce another fourth one, which now will be the one that is doing what we call handshaking. And what is now this fourth pin doing? It will create a system so that the second device sees the information that is sent, and then it tells that, yes, I am clear and ready, please send. And that information is going to be sent back to the sender to say, I've acknowledged your information, please send what you need to send. Now, this guarantees that whatever I'm sending that side, it's going to be acknowledged. So that is where now this handshaking concept means, okay? So this now technically will go step by step doing all this information. But you are probably asking yourself, when these messages are being sent, what type of messages are being sent, first of all? Secondly, what protocol is being used? How do they acknowledge each other? What if the sending end and the receiving end are using different protocol? Will the message be able to be received by the receiving end device? Now we are talking about that communication in that pyramid that we are referring to. When these messages are being sent, okay, basically the messages are broken down into individual characters, okay, and transmitted 1 bit at a time. That's the first operation of how this works. Now, what they did, I'm not going to go too much on networks. I don't know whether you guys have done networking before, but I'm just going to give you a small background to understand so that this can be able to assist you with what we are trying to do. There was a group that sat down, okay, and then they developed what we call ASCII. Probably you have heard of that. It's a very popular group. And what does ACSSI, SCII stand for? It stands for the American Standard Code for Information Interchange. Okay. Now, this committee, when they sat down, the idea was to make sure that the communication between the devices are standardized so that nobody just creates his own thing. What do I mean by that? We have a language that's called English, and the English that is that we are speaking in South Africa is the same English as the one that is being that people in America are speaking, people in different continents are speaking. Once you go to a person and you say, "Do you speak English?" and the person says, "Yes, I speak English," automatically you guys are going to understand each other, because we all got common ground of what we know as English. Now, how did that come up? It became an international communication standard because they sat down and they created characters that means same thing in any other English that you can find there. For example, when I say to you, "Stand up," every speaking person will understand what stand up means, okay? As long as that person understands English. It's the same thing with this American Standard Code for information interchange. When they looked at all these characters that are used for communication, they made a point that they standardize everything, okay? Meaning now they look at all these letters that are being broken down and special characters that have binary coded equivalent are all the same for all devices that are ASCII compliant, okay? So when they designed that, they created a 7-bit and an 8-bit, which now the 8-bit was the extended of ASCII. Now there's a lot of literature behind that, okay? In our case, we just need to understand that there's this common code standard that is used for communication, and it's based on 7-bit and 8-bit, okay? Now, when it comes to the 7-bit ASCII, there are 128 possible different letters, numbers, and special characters. Where the 8-bit, it's got 256 possible different letters, numbers, and special characters, okay? And each character means a specific information, okay? So there's a lot of literature behind this, but I'm just now giving you a breakdown so that you'll understand. Once the device is ASCII compliant, what does that mean? Okay, all right. Now let's look at the example of what I just explained.